I wish a very good evening to all of you. I welcome you to class 2 Gate online live class civil engineering class 2, that is session 2 of geotechnical engineering, for which is a very high weighted subject whose weightage, as I told you, ranges from 14 to 16 marks. So we will be solving very important questions and the method of approach and how to solve them quickly in today's session. Okay, these are the questions that we have discussed in the previous sessions. So let's quickly start up with the questions. Once please confirm me, all of you from your end, is my voice audible to all of you or not? Is my voice audible to all of you or not? Please confirm me, my dear students. Very good, Selvanayaki. Very good, Kirtika. Thank you. Thank you. And my screen is visible to all of you. And here I am writing something. The question number, that is Z Gate 2025 set 1, 2 marks. Can you all see this that I am writing on the top of the screen, top left corner? Is it visible? What I am writing, is it visible to all of you? Is it? Please confirm me if it is visible to all of you or not, so that we will quickly start up the session. Can you see this? Yes, thank you, Kirtika. Okay, so this is a question from GATE 2025, set 1, 2 marks. Already we have solved ample number of questions only from 2025. That is more than 18, 19 questions we have solved in the previous session. All are of them are from GATE 2025 itself. That means it itself tells how important the subject is in every GATE examination. The standard plasticity chart, as per this question states, the standard plasticity chart for the classification of a fine grained soil. It is directly given. The type of soil is fine grained soil, my dear students, as shown in the figure. As per Indian Standard Soil Classification System, that is, the system is ISECS, Indian Standard Soil Classification System. X represents, so X is a type of soil, because as per the options it is given inorganic clay with medium plasticity, inorganic silt with medium plasticity, inorganic clay with high plasticity, inorganic silt with high compressibility. This is A line, my dear students. Okay, and this, there is a graph plotted, in A line graph, the graph is plotted between plasticity index and liquid limit. Okay, so equation of A line. What is equation of A line? I'm explaining it. Equation of A line is given by, can you tell me, my dear students, can you guess what is the equation of A line? Anyone? Also inform your friends, my dear students. Inform your friends also to join faster. What is the equation of A line, ma? Anyone? Okay. Equation of A line is given by 0.73 into WL minus 20. Okay. Plasticity index is given by 0.73 into WL minus 20. WL is the liquid limit, my dear students. 0.73 into liquid limit of soil X. He is asking about soil X. So X from the graph I can say it is greater than 50. So X is greater than 50 minus 20. Okay. And there is no need to find the A line equation. Already I can say the soil X is lying. Soil X is lying above A line. Soil X is lying above A line, and soil X is also lying right to liquid limit of 50%. That means soil X is having a liquid limit of greater than 50% also. So any soil whose liquid limit greater than 50%, I can say as per IS, the codal provision I am writing 1498. This is the code number 1970, last modified year as per IS Indian Standard Soil Classification System 1498 1970. Any soil, any fine grained soil whose liquid limit is greater than 50%, we call it as high plasticity soil. So here the soil is having liquid limit greater than 50%. Since X is on the right of 50%, therefore it is highly plastic. So high plastic, high compressible, both being the same. And now we need to confirm it whether it is clay or silt. Listen, my dear students, soil lying above a line, we call it as clay. Soil lying below a line, we call it as silt. Okay. So here the soil X as per the diagram is lying above the A line. Therefore, we call it as clay soil. So one thing is very sure, it is a fine grained soil. Fine grained soil means it might be say clay, silt, clay or silt. So one thing is very clear, soil is lying above a line. Therefore, I can confirm it to be clay. And next, liquid limit is greater than 50%. I call it as high plasticity soil. Therefore, it is inorganic clay with high plasticity. Option C is our answer. Am I clear to all of you? Am I clear to all of you, my dear students? Please message me. It is clear. If it is clear to all of you. If not, if anyone have any doubts, I'll be giving a minute here. Please ask me your doubts. Then we will be moving to our next question. Even a small doubt of you will be valuable. Don't keep your doubts in yourselves. Inform me in the chat box, my dear students, whether I'm clear to all of you or not. Ask me if you have any doubts. If not, please message me no doubts or clear so that I'll move to the next question immediately. Okay, my dear students, and moving on to the next question. This is also a question from GATE 2025, set 1. This is a question, I can say it is from shear strength, because the x-axis is showing sigma stress and shear stress is on y-axis. The graph is plotted. The results of consolidated drained triaxial test, CD, consolidated, soil is consolidated on both sides and drainage is allowed on both sides. That is consolidated drained triaxial test on normally consolidated clay are shown. Angle of internal friction is how much is the question. Now, can you tell me what are the conditions for a consolidated test? What is the value of cohesion? Listen, my dear students, let me explain this. For consolidated drain test, we have some initial conditions. Consolidated drained test, we have C, cohesion angle of cohesion, value of cohesion is 0. So from the equation of plastic equilibrium, we have the equation, we have the formula sigma 3 tan square alpha plus 2c tan alpha, where alpha is equal to 45 plus 5 by 2. And from this, from since it is mentioned CD test, I can say C equal to 0. Therefore, the plastic equilibrium equation transforms like this: sigma 3 equal to sigma 1 equal to sigma 3 tan square alpha, that is sigma 3 tan square of 45 plus 5 by 2. Now, listen, my dear students, where here I am taking sigma 1 is the major principal stress, that is sigma 1. From the diagram, I can take sigma 1 equal to 100. Sigma 3 is the minor principal stress, sigma 3 equal to 50. Therefore, on substitution in this equation, I'll be getting 100 equal to 50 into tan square 45 plus 5 by 2. Now, tan square 45 plus 5 by 2, I can write it as, because I was given the answers in sine. So, we need to convert tan square to sine. Tan square 45 plus theta, sorry, tan square 45 plus, yeah, theta, that can be written as 1 plus sine 2 theta, that is in theta we have 5 by 2, by 1 minus sine 2 theta. So 2 and 2, 2 and 2 will get cancelled. That gives 1 plus sine phi. That is, during solving this question, we need to know trigonometry as well. That is, this question is linked to geotechnical engineering as well as trigonometry. 100 equal to 50 into 1 plus sine phi upon 1 minus sine phi. From this, my dear students, if I am taking this 1 minus sine phi to the left side, that gives 100 minus 100 sine phi is equal to 50 plus 50 sine phi. From this, I will be getting 150 sine phi is equal to 50. Sine phi is equal to 50 by 150, that is 1 by 3. From this, phi equal to sine inverse 1 by 3. Therefore, our option is option B. Is it clear to all of you? Please do respond, my dear students. Am I clear to all of you? Please let me know if anyone have any doubts in this. I'm giving a minute here for you all to understand this question. Am I audible to all of you? Please let me know. Am I audible to all of you? In the chat box. Yes, thank you, Vijayalata. Um, is my voice and is the screen visible to all of you? On last confirmation from my side, from your side. Yes, thank you, Biza. Is the question clear to all of you? Do you have any doubts in this question? Please ask me. Anyone, if you have any doubts, please ask me. Else, please message me. No doubts or clear to all of you, please. If anyone have any doubts, you can ask me at the same time, or else after the question. I'll be giving a minute after every question. Okay. If it is clear to all of you, I'll move to the next question immediately. Thank you. Listen, my dear students. The next question is stating. Next question states. A drying triaxial test was conducted on a saturated sand specimen. Drying triaxial test was conducted on saturated sand specimen using stress path triaxial testing system. The specimen failed when axial stress reached a value of 100 kilonewton per meter square from an initial confining pressure of 300 kilonewton per meter square. The angle of shearing plane with respect to the horizontal is angle of shearing plane is asked. That is nothing but angle between major plane and minor plane. Angle of shearing plane with respect to horizontal means the angle between major plane and angle between major and minor failure plane. Major and minor failure plane. Major, or else I can say it is angle between minor plane and failure plane. That is nothing but first we need to calculate phi, and next we need to calculate the angle between minor plane to the failure plane. Listen, let me draw the diagram, my dear students, here. Where he told axial stress reached a value of 100. So this is the axial direction, my dear students. So that is axial direction means we have minor principal stress sigma 3 equal to 100. This is MNPS, minor principal stress. From an initial confining pressure is horizontal pressure, that is major principal stress MJPS, where sigma 1 is equal to 300. Okay, the angle of shearing plane is asked. So listen, my dear students, this is minor principal plane, this is major principal plane, and it is given what type of test. drain triaxial test. So drained test, as I told you in the previous question also, drained test, what is the cohesion? For drain test, what is the value of cohesion? Even if you don't know, my dear students, I'll tell you a tip here. Anything that you don't know, safely assume it to be zero. Especially in soil in these conditions, if the data is not given, don't assume any other value. Directly assume it to be zero. For drain test, cohesion, and it is CD test, whatever it might be, drain test, drain condition, cohesion C is considered zero. And the plastic equilibrium condition is sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. And we know drain test C equal to 0. Therefore, sigma 1 is equal to sigma 3 tan square alpha. And sigma 1 is 300, sigma 3 is 100 tan square alpha. So tan square alpha, I get it as 3. Tan square alpha equal to 3 means, my dear students, tan alpha equal to root 3. So tan alpha is root 3 at which angle? Respond. Tell me the answer. Tan alpha is root 3. At what angle is angle of alpha is tan alpha root 3? At what angle is it? Tan alpha is root 3 at angle alpha is equal to 60 degree. Angle alpha is equal to 60 degree. Now, he is asking us angle of shearing plane with respect to horizontal. With respect to horizontal, the angle of shearing plane will be like this, my dear students. So this is the shearing plane, and if these both are the angles, he is asking us angle of shearing plane with respect to horizontal. So in the red mark what I have drawn, that is being asked. That is with respect to the horizontal angle of shearing plane. With respect to horizontal means that is nothing but angle between minor principal plane and the failure plane, because it's with respect to horizontal. If it is with respect to vertical, we would have taken the otherwise. That is major principal plane and the shearing plane. So since he had asked us the angle between angle of shearing plane, this is your shearing plane with respect to vertical, that means the minor principal plane. Therefore, angle of shearing plane with respect to horizontal is equal to angle between minor principal plane and failure plane, that is equal to 45 minus 5 by 2. And if it is with vertical, it will be 45 plus 5 by 2. So alpha is equal to 60 degrees means what is phi? We know alpha equal to 45 plus 5 by 2. That is 60 is equal to 45 plus 5 by 2. So 5 by 2 is equal to 60 minus 45, that is 15. Phi equal to 30 degrees. Once we substitute this 30 degrees here, that gives you 45 minus 30 by 2, that is 45 minus 15, that is again 30 degrees. Therefore, the angle of shearing plane with respect to the horizontal is 30 degrees. In degrees is mentioned, nearest integer, the answer is 30. Please have a look at this question. I'm giving a couple of minutes here to understand this question and to ask any doubts. If anyone have any doubts, you can please let me know. If not, please message me in the chat box that No doubts are clear. So that I'll move to the next question, my dear students. Explain it once more. Which part, my dear? Very good. Thank you for asking, Tangaveni. Listen, it is given drawing test. Drawing test itself means we need to take cohesion C is equal to 0. Am I clear with it or not? In the previous question also, I'll be showing you where drawing test, consolidated drawing test, we have taken C is equal to 0. Blindly, if it is given drawing test, take C is equal to 0. He asked us angle of shearing plane. This is the angle of shearing plane, inclined plane. With respect to horizontal, that means this angle we need. This angle is between shearing plane and minor principal plane. That is 45 minus 5 by 2. This angle is 45 plus 5 by 2. So what are we asked? 45 minus 5 by 2. So first we need to know phi. How to know phi? From again using any shear strength test, directly use plastic equilibrium equation. What it is? Sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. So I am writing sigma 1 equal to sigma 3 tan square alpha. I am eliminating 2c tan alpha because c is 0. And axial stress is minor principal stress, confining stress is major principal stress. That is sigma 3 is 100, sigma 1 is 300. 300 equal to 100 tan square alpha. From this I got tan square alpha is 3, tan alpha is root 3. At what angle is tan theta root 3? 60 degree. Alpha is 60 degree. But we know from plastic equilibrium equation alpha equal to 45 plus 5 by 2. From this I calculated phi as 30 degree. Now going to our question, angle of shearing plane with respect to horizontal. With respect to horizontal means we need to take the value 45 minus 5 by 2. So 45 plus 5 by 2 is 60 we got. So 45 minus 5 by 2 means 45 minus 30 by 2. The answer is 30 degrees. Instead, if he asked us vertical, it would be 60. Since he asked us horizontal, it is 30. Am I clear to all of you? Any more doubts in this question are most welcomed. Clear? Thank you, Tangaveni. What about others? MJPS major principal stress, MJPP major principal plane, MNPS minor principal stress. MJPS means sigma 1, MNPS sigma 3 minor principal stress, MNPP minor principal plane, MJPP major principal plane, FP, this is FP. What is this inclined plane? Failure plane. Very good, Janani. Thank you. FP failure plane, SP shearing plane, shearing plane or failure plane, both same. Shearing plane and failure plane both are the same. This one only. Am I clear to all of you now? That is the reason I'm asking you to ask doubts, my dear students. Please don't be calm. I'll be explaining anything, any doubt. If it is clear to all of you, I'll be moving to the next question. Okay, moving on to the next question. Then This is a 2-mark question from GATE 2024 set 2. Finally, we moved on to GATE 2024 questions at least. From 2025, lot of questions we have solved it. The in-situ percentage of voids of a sand deposit. Voids percentage is given, my dear students, 50%. That is volume of voids to total volume. That is void ratio. Sorry, not void ratio, porosity. N is given. Percentage of voids. Void ratio E is VV by VS. Maximum and minimum densities of sand is 1.8 and 1.3. That is gamma D max is given, gamma D minimum is given. Specific gravity of sand 2.7. It's a sand deposit. Relative density index is dash rounded off to 2 decimal places. It is not asked in percentage, so let's take it in decimals. So relative density, we have a formula, that is E max. If it is in void ratio, we write it like E max minus E by E max minus E minimum. We can write like this. If required in percentage, multiply into 100. If not, you can leave it like this. And how to get it in, because we have it in gamma max and gamma D minimum. It is sand, we assume it as gamma D max, gamma D minimum. Gamma D max means in dry dense state, dry density is maximum. In dense state, dry density is maximum. Okay, in dense state means E void ratio will be maximum or minimum. Tell me, my dear students. If gamma D max means dense state, that is void ratio, voids will be minimum. Voids will be minimum means void ratio will be minimum. Therefore, I can use a formula E minimum is equal to G gamma W by gamma D minus 1. And similarly, E maximum is equal to, here we have minimum, take gamma D maximum. E maximum is equal to, void ratio will be maximum when in loosest state. Loosest state means dry density will be minimum minus 1. Calculate, gamma D max 1.8, gamma D minimum 1.3, G is 2.7, gamma W you take it as 1 gram per cc. Calculate and tell me E minimum and D maximum, and then substitute and find the value of relative density. Only formula oriented questions. And how you got this, I'll explain you here. Gamma D, we know the formula G gamma W by 1 plus E. And from this, if I want E, I am taking 1 plus E equal to G gamma W upon gamma D. And E equal to G gamma W by gamma D minus 1. And here he had given, we don't know gamma D. We know gamma D max, gamma D minimum. Gamma D minimum means E max. Gamma D maximum, E minimum. Therefore, he had given percentage of voids of a sand deposit. Percentage of voids means volume of voids by total volume, that is porosity. Porosity is given 50%, 0.5. N is equal to E by 1 plus E, or else E equal to N by 1 minus N. From this we will be getting value of E. From this we will be getting E minimum. From this we will be getting E maximum. On substitution we will be getting relative density. Take a couple of minutes and tell me the answers, my dear students. How much is E? How much is E maximum? How much is E minimum? Please tell me the answer of E, my dear students. How much is the answer of E? Anyone? If I am substituting given percentage voids is 50%, that is zero point 0.5. E is equal to zero point 0.5 by 1 minus zero point 0.5. How much is it? Very good, Ashika. Very good, Janani. E is equal to 1. Very good. Now, how much is E minimum then? We know G is 2.7 into gamma W1 by gamma D max 1.8 minus 1. How much is the answer? 0.5. Very good. Very good. Because 2.7 by 1.8 is 1.5. E minimum is 0.5. Next, what is E maximum? That is again 2.7 into 1 by 1.3 minus 1. How much it is? How much is the value then? E max is greater than 1. Please calculate it, my dear. 2.7 by 1.3. If it is 1.35, Emax would be 1, my dear students. Emax should be greater than E. Always, my dear students, this should be order. Emax should be greater than E. E should be greater than E minimum. So 2.7 by 1.3. What exactly is the answer? 1.076. Very good. 1.076. That means I can round it to 1.1 also. Let me check it. Yeah, 1.0769. That is 1.077. I can finally round it to 1.08 also, if I'm clear. So, substituting all these values here, 1.08 minus 1 by 1.08 minus E minimum is 0.5. How much is the answer? What is the answer, my dear students? I had simply substituted this E max, E minimum. I got the values. I substituted everything in relative density. We can also call it as density index, ID. I means index, E means density, RD, relative density index, all are same. What is the answer then? Very good, Janani. 13.79%. Very good. But he asked us in percentage. Relative density index is asked, not in percentage. He had not mentioned in percentage. If it is mentioned in percentage, you need to multiply it into 100 mark. But it is not mentioned in percentage. So decimal, direct decimal, what we have, you can take it. Very good, Selvanaiki. Very good, Janani. Yeah, 0.1379 will be the answer. 0.14 because it is asked to round to two decimal places. As per the key, it is 0.12 to 0.15. Any value is right. Please let me know if anyone have any doubts. If not, please message me in the chat box. It is clear to all of you, so that I'll move to the next question. Okay, my dear students, the next question, it is from GATE 2024, set 2 and 2 marks 1. It is given a homogeneous earth dam has a maximum water head difference of 15 meter between upstream and downstream sides. That is, between upstream and downstream side, you have the water difference means that is your head loss, total head loss. Del capital H is total head loss. 15 meter is given, total head loss. A flow net was drawn. So this is a question from flow net. With number of potential drops n, nd, 10. Average length of each element 3 meter. L is equal to 3 meter. Specific gravity of soil Z 2.65. Factor of safety against piping failure 2. void ratio of soil is dash. So first let's calculate equipotential drops. Equipotential drop of every channel. Here it is given total head loss. If equipotential drop of every channel, that is, my dear students, 15-meter head difference is you are having in 10 drops. So in one drop, how much is the head difference? So that is del H by ND, number of drops. ND is 10, del H is 15. Equipotential drop of each channel is 1.5. Factor of safety against piping, that is nothing but quicksand condition, is given by the formula I critical upon I. I is hydraulic gradient del H upon L. Head loss per unit length. Head loss is nothing but equipotential drop per channel. 1.5 meter per length is 3 meter. That is I is equal to 0.5. And I critical is critical hydraulic gradient. Critical hydraulic gradient. So this is a question involving hydraulic gradient, seepage, as well as flow net. So critical hydraulic gradient is given by the formula Z minus 1 upon 1 plus E. So critical hydraulic gradient, but we know we are given factor of safety to be 2. 2 equal to I critical upon I, where we got I equal to 0.5. I critical is equal to 2 times I, that is twice 0.5 is 1. We got I critical is 1. We know G is 2.65. From this, please substitute and tell me the answer of E, my dear students. I am explaining again. It is given the total water difference is 15 meter. Total head loss, that is number of drops is 10. From this I can calculate head loss per each drop, each channel, that is equipotential drop of each channel, del small h, that is capital del H by ND. I got del small h. He had given factor of safety against piping, that is quicksand condition piping means, that is ICR by I. But FOS is given 2. So from this we calculate I is del H by L. ICR is Z minus 1 by 1 plus C. We know D is 2.65. Very good, Selvanaiki. You got 0.65. Yes. From this I substituted here. I got value of void ratio to be 0.65. Everyone have a glance, have a look at it. Please let me know if anyone have any doubts. If not, message me clear in the chat box. I'll be moving on to the next question then. Take a minute here. So moving to the next question, my dear students, can you please guess the answer for this? Anyone? Please take a couple of minutes, guess the answer. When a rough retaining wall moves towards, see, we have two statements, statement P and Q. Both are related to analysis or design of retaining wall. P is stating when a rough retaining wall move towards the backfill, wall friction or resistance mobilizes in upward direction along the wall. Second statement states most of the earth pressure theories calculate the earth pressure due to surcharge by neglecting the actual distribution of stress due to surcharge. It's a two-mark question in GATE 2024. Kelly asked, which is focused on the topic retaining wall and earth pressure theories of geotechnical engineering subject. Please, I am expecting everyone to guess an answer for this. When a rough retaining wall D P is false and Q is true. We'll check out Selvanaik. Don't worry. Listen, ma. When a rough retaining wall moves towards the backfill, towards the backfill, yes, then wall friction mobilizes in upward direction. Wall friction mobilizes in upward direction. When it moves away from backfill, friction mobilizes in downward direction. So towards passive resistance, friction mobilizes in upward direction. Away, active resistance, friction mobilizes in downward direction. So you remember like this. Towards, you can see the diagram like this. Very good guess even. This is our wall. This is our wall. This is our backfill. This is our backfill. This is at an angle delta. Passive force, PP means passive force. Then angle of friction will be mobilized upwards like this, inclined upwards. And passive force will be in this direction, moving towards the backfill. Retaining wall moving towards the backfill in this direction. Retaining wall, retaining wall is moving towards the backfill in this direction. Friction is mobilized upwards. Most and the next thing, most of the earth pressure theories calculate earth pressure due to surcharge by neglecting actual distribution of stress due to surcharge. Yes, 100%. Earth pressure due to surcharge is assumed to be constant along the depth of retaining wall, and the actual variation of stress is neglected due to surcharge. So what it is told is 100% right. So both P and Q are true. Option A matches our answer. Please have a glance at it. I'll move to the next question then. If it is done and dusted. Please message me, my dear students, if anyone have any doubts. If no messages, I'll treat it no doubts. I'll be going to the next question. Okay, moving on to the next question, my dear students. The next question is in GATE 2024 again, set 2. A reinforced concrete pile. There is one pile given of length 10 meter. Listen, I am assuming it is the ground surface. The pile length is mentioned 10 meter length of pile below the ground level, my dear students. In a saturated pure clay, all this layer is saturated pure clay. Saturated pure clay with cohesion 50 kilopascal, 50 kilonewton per meter square. Adhesion factor 0.5. In clay we have adhesion factor. Net ultimate pullout capacity. It is mentioned concrete pile. It is mentioned concrete pile. Net ultimate pullout capacity of the pile is dash. Net ultimate pullout capacity means, my dear students, what is, in order to pull it out, what is the opposing force? So one thing is the friction. In order to pull it out, net ultimate uplift pull out capacity. In order to lift it upward, in order to pull it out, what is the opposing force? Can it be fully? Can it be pulled freely? No. The opposing will be its weight, the weight of the pile acting downward. It is a concrete pile. And next, the friction, the load due to friction also acting downward. So both the things adding will give you net ultimate pull out capacity. So we need to calculate two things. One thing load due to friction, the other one is weight. Add both the things, then you will be getting the net ultimate pull out capacity. Load due to friction. How do we add this? Weight is nothing but how do we get the formula for weight? It is made of concrete. That is gamma C, unit weight of concrete. That's nothing but 25. Unit weight of concrete is 25 kilonewton per meter cube. This is weight plus into area pi d square by 4. This with multiplied with area pi d square by 4. Pi into d is diameter 0.7 whole square by 4 into unit length. So 25 into pi into 0.7 whole square by 4 plus load friction, load due to friction, side friction, that is alpha c bar as. As is pi dl. Alpha c bar as, that is pi dl. Alpha is adhesion factor 0.5. C bar is 50 into AS. Pi into D is diameter zero point 0.7 into L will be your 10 length. What is this answer? Alpha C bar AS. How much is it? Or else do one thing, my dear students. There is even gamma C is not given clearly. Even if you take it, it is not a problem. Gamma C unit weight of concrete is not given clearly. No need of assuming it. Directly take load due to side friction, because in order to uplift it, friction is hardly resisting. So nothing but, and when you are taking the load carrying capacity, then only take this base resistance QB, and if you are taking net pull out, only consider skin friction resistance QSF. Since we are talking about net ultimate pull out is nothing but your, what is resisting? Only skin friction is resisting. Skin friction forces alpha C bar AS in clay. That's it. Alpha C bar AS, we know alpha, we know C bar, we know AS pi dl surface area. Calculate and tell me the answer. If gamma C unit weight of concrete is given, and if it is mentioned, consider unit weight of concrete also, then we need to take this gamma C into pi d square by 4 into length. But it is not mentioned to be considered, so there is no need of it. Also, gamma C is not given, that means he is indirectly telling to ignore. Calculate and tell me the answer. I'll be waiting for your answer. Very good, Ashika. 550. So the answer we got is 549 point something. Nearest integer is 550. So alpha is 0.5, C bar is 50. Yes, is pi dl. Nothing very difficult in this. 550 we are getting in kilonewton. And as per the key, it is mentioned 545 to 555. Any answer is correct. So please let me know, anyone, if you have any doubts in this. I'll be waiting for your doubts for a minute. Okay, my dear students, we'll be moving to the next question then, stating it as very clear to all of you. So the next question, which of the following saturated fine-grained soils can attain a negative Skempton's pore pressure coefficient? Negative Skempton pore pressure coefficient, my dear students, for which we will be getting. We have Skempton's pore pressure coefficients, two types, A and B. We are talking about A value for which it is negative. Can you guess for a while? I'm giving a minute. Listen, my dear students, which of the following saturated fine-grained soils attain a negative Skempton's pore pressure coefficient A? Skempton pore pressure coefficient A, I'm writing it down. It is very large, that is of the value 2 to 3 for saturated fine sand, of the range 2 to 3 for saturated fine sand, that is for very loose soils. A ranges 2 to 3, and normally consolidated clay, it ranges from 0.5 to 0.1, 0.5 to 1. Value of A for NC clay, normal consolidated clay, and light consolidated clay, it ranges between 0 to 0.5. Sorry, even greater than 0.5 light consolidated clay. So I can say activity for over consolidated soil or over consolidated clay, activity is a function of over consolidation ratio. Okay, for over consolidated clay we have pore pressure coefficient less than 0, which will be like minus 0.5 up to 0, not less than minus 0.5. So a slight lesser negative value we will be getting for Skempton pore pressure coefficient in case of over consolidated clay. I am writing the values for everything. Light consolidated clay greater than 0.5 and normal consolidated clay 0.5 to 1. Quick clay very high. Saturated fine sand, loose one, quick clay, 2 to 3 or even more. Over consolidated clay, we have it negative. So these are the values you need to remember. Please let me know if anyone have any doubts in this. I'm giving a minute here and we'll be moving then to the next question if it is clear to all of you. I'm repeating once again. If anyone have any doubts, you can feel free to ask me. So the next question, it is also a GATE 2024 set 1 question. It is mentioned a soil sample was consolidated at a cell pressure of 20 kilopascal. Listen, my dear students, cell pressure 20 kilopascal, back pressure 10 kilopascal for 24 hours during a consolidated undrained triaxial test. On next day, what happened? The cell pressure was increased to 30 kilopascal. It resulted in development of pore water pressure of 1 kilopascal. The sample failed when the axial stress was gradually increased to 50 kilopascal. The pore water pressure at failure was recorded as 21 kilopascal. Skempton pore pressure parameter B for soil sample is dash. So he had asked us one thing, my dear students, Skempton's pore pressure parameter, that is delta UC by delta sigma 3. So how much is sigma 3 initially? Cell pressure sigma 3 is 20 kilopascal initially. Back pressure 10 kilopascal, and the cell pressure increased to 30 kilopascal, that is sigma 3 dash. Finally, next day, sigma 3 dash increased to 30 kilopascal, and when it increased, pore water pressure delta UC 1 kilopascal. And what is delta sigma 3? Pore water pressure is increased when the cell pressure was increased. When the cell pressure was increased, 30 minus, sorry, delta UC is 1 divided by delta sigma 3. How much it is? 30 minus 20. From 20 to 30, that is 30 minus 20, that is 10. That is 1 by 10. The answer will be 0.1. Skempton pore pressure parameter B. Or else if you take the other range, it increases from 1 to 21. Formula will be same, delta UC by delta sigma 3. Some people will be having a doubt. Why are we considering the only increase of 0 to 1 water pressure? Why don't we consider it from 1 kilopascal to 21 kilopascal? Yes, you can consider. From 1 to 21, that is 21 minus 1. But this is the failure condition. But this is the failure condition. So we are not considering. So that is the reason B equal to del UC by del sigma 3, where del UC is increase in pore water pressure when it is increased from 20 kilopascal to 30 kilopascal. Delta sigma 3 is nothing but sigma 3 dash minus sigma 3. Please have a look at it and let me know if anyone have any doubts in this. Here some people will be having a doubt. why back pressure of 10 kilopascal is not taken. Listen, my dear students, all the data given in the equation need not be taken. There is no such need. All the data should be used in the equation. Back pressure is only for saturation, not for calculation of B directly. After consolidation, what happened? Cell pressure increased to 30. Next day, cell pressure increased to 30 because consolidated and drained. After consolidation, sigma 3 became sigma 3 dash. Cell pressure increased to 30. Okay. Therefore, B equal to delta UC by delta sigma 3, and delta sigma 3 is equal to sigma 3 dash minus sigma 3, that is 30 minus 20, 10 kilopascal. Delta UC is given as 1 kilopascal. And someone even will be having what is axial stress and why axial stress was increased to 50 kilopascal, and why it is ignored, and why is failure pour water pressure 21 kilopascal, why it is ignored. Listen, my dear students, B is Skempton's pour water pressure parameter. B measures the pore pressure response only due to change in cell pressure, not due to axial loading, not due to shear loading. B takes into account only due to change in cell pressure. How is the pore pressure varying? In CU triaxial test, B is measured during isotropic loading before axial stress is applied. Drain valves are closed. Only cell pressure is changed. Okay. Axial stress causes shear deformation, volume change tendency, pore pressure generation due to shearing. But nothing is used in calculation of B. Therefore, in B, we only use the calculation of del U, that is change in pore water pressure when change in cell pressure, that is B equal to delta UC by delta sigma 3. I hope it is very clear. I'm giving a minute to understand or ask any doubts. I'll be waiting for you, my dear students. I'll be waiting for a minute. If there is no doubts, I'll be moving on to the next question. Yes, any more doubt for anyone? Okay, I'm moving on to the next question. An infinite slope. This is GATE 2024 set 1 question. An infinite slope is made up of cohesionless soil, no cohesion, that is, it might be sand mostly, with steepness parallel to and up to the sloping surface. The angle of slope is 30° with respect to horizontal ground surface. Unit weight of saturated soil and water. Saturated soil gamma sat is given 20 kilonewton per meter cube. Gamma W is given 10 kilonewton per meter cube. The minimum angle of shearing resistance of soil for critically stable condition of slope. For the slope to be stable, what is the minimum angle of shearing resistance? More shearing resistance, more stable. But just for the slope to be critically stable, what is the minimum angle of shearing resistance? He is asking us to the round off to the nearest integer. So listen, my dear students, we have a factor of safety equation. And why are we taking factor of safety? How much we need to take it? I'll be telling you. Factor of safety is equal to gamma dash. That is nothing but gamma submerged. Gamma dash, you can also write it as gamma submerged. Both means nothing but gamma sat minus gamma W into tan phi by tan beta. Beta is angle of slope with horizontal. Angle of slope with horizontal is nothing but beta. And critically stable, just stable condition, factor of safety is 1. So take it 1, and gamma dash, gamma sat minus gamma W, that is 20 is gamma sat, gamma W is 10. 20 minus 10 is 10 kilonewton per meter cube. Gamma dash is 10. Gamma sat is given 20 into tan phi upon tan beta is tan 30. Listen, my dear students, factor of safety, the formula for a cohesionless soil with seepage parallel to the sloping surface is given by gamma dash by gamma sat into tan phi by tan beta. Since it is saturated, if it is unsaturated, you would have taken gamma simply. Okay. So factor of safety. From this, I am expecting you, I want you to calculate the value of phi and tell me the answer. Why FOS is taken to be 1? Most of our doubt. Because for critical stable condition, we are assuming just to be stable, factor of safety, assume it to be 1. Beta is angle of slope with horizontal surface, assume it given 30°. So just a mere substitution, factor of safety is gamma dash by gamma sat into tan phi by tan beta. FOS is assumed 1. From this calculate tan phi. I'll be waiting for your answers. Very good. 49. Very good. Even now, in the key also it is given 49 to 50. The exact answer is 5 is equal to 49.10. So nearest integer is 49. Very good, Ashika. The answer should be 49 degrees. In degrees is asked, therefore nearest integer is 49. Wonderful. Anyone? If any doubts, please ask me. I'll be explaining you. I'm giving a minute here. If you ask me for any doubts. So moving to the next question. This is a GATE 2024 question from set 1 and 2 marks. The question is telling us the total primary consolidation of a building constructed on 10-meter thick saturated clay layer is estimated 50 mm. After 300 days of construction of building, primary consolidation was reported as 10 mm. The additional time required in 300 days, you got 10 mm. Additional time required to achieve 50% of total consolidation. Always remember, my dear students, total consolidation is constant. So he is telling us total consolidation is 50 mm, and after 300 days we have 10 mm. That is how much percentage of it. And he is asking 50%. 50% of 50 mm is 25 mm. So we need two things. Time factor EV is given by a formula CV T by D square, and time factor is also given by the formula pi by 4 u% by 100 whole square when degree of consolidation is less than 60% or equal to. Here we are asked to achieve 50%. Is 50 less than 60? Tell me. Yes, 50 is less than 60. Then we can use this formula. And this formula is constant always. And now first let us see for 10 mm settlement. For 10 mm settlement, what is percentage consolidation? Percentage U, how much it is? 10 divided by total consolidation is 50 into 100. For 10 mm settlement, percentage U is 20%. And next we require for 50%. Next settlement, percentage U is nothing but given 50%. And we know the formula TV equal to CVT by T square. And that means in 20% and 50%, let's take two conditions. CV is a constant parameter. TV, time factor, which is a constant parameter. TV is constant. CV is constant. So only variable parameters are T1, T2. Sorry, TV is not a constant parameter. D is a constant parameter because even with time also, this thickness is not changing. That is constant. And TV is pi by 4 U by 100 whole square. TV is pi by 4 U by 100 whole square. That is equal to CVT by D square. So the changing parameters here are U percent U1, for 20% it is U1, 50% it is U2. For 20% it is T1, 50% it is T2. So from this what I can write, TV proportional to small t and TV proportional to U square. Therefore, what I can write is T1 by T2 is equal to U1 square by U2 square. Please, all of you have a glance at it. What I had done is TV is a time factor that is given by the formula pi by 4 U by 100 whole square. In this, pi is constant, 4 is constant, 100 is constant, 2 is constant. Only variable is the percentage of consolidation U. And next, TV is given by one more formula, CVT by D square. This holds good for U less than or equal to 60. Luckily, in our question, U less than or equal to 60 only. And TV equal to CVT by D square. In the CV is constant, D is constant. So, the only relation we can take is TV proportional to T from this and from this. TV proportional to U square from these two equations. Therefore, T proportional to U square. That means T1 by T2 equal to U1 square by U2 square. From this I want T2. Because T1 is initial 300 days mentioned. T1 U2 square into U2 square by U1 square. How much is T1? 300 days. In 300 days, how much is settlement? 10 mm. 10 mm is how much percent? See, U2 is 50%, 50 square by U1 is 20%, 10 mm means 20%, 20 square. From this, what is the value of T2? Tell me, my dear students. What is the value of T2 from this? Please let me know. Very good, Ashika. Very good, Selvanayaki. 1875 days. Okay. Okay. We got 1875 days. Okay. But is it required? The additional time is asking. He is not asking time. Additional time means out of total 1875 days, in first 300 days, 20%, 10 mm is done. So for complete 50%, how many extra days are required? Additional time means 1875 minus this 300. What is the answer? Because he is not asking simply the time, he asked us additional time. So 1875 minus this 300, that is 1575 days. So answer will be 1575 days. 1575. Please let me know if anyone have any doubts in this. We have only taken two parameters, TV equal to CVT by D square, TV equal to pi by 4 U% by 100 whole square. In this, CV is constant, D is constant, pi is constant, 100 is constant, 4 is constant. Only variables are small t, that is time, and degree of consolidation. As we know, degree of consolidation increases with time. But in what ratio? T proportional to U square. This holds good only up to a degree of consolidation of 60%, my dear students. Please let me know if anyone have any doubts in this question or else in the previous questions. No doubts. We are going to stop here for tonight. And I had covered. Okay, I'll be waiting for your doubts initially for a couple of minutes. Tomorrow in the morning at 9 o'clock, we will be having two sessions back to back. Very, very, very important. I'm telling you, my dear students, very important, because the sessions are related to environmental engineering. I'll be quickly discussing very important problems. Most of them you can see in the gate examination. Please share to your others, friends as well. Which part, Ashika? Please tell me. Can you please explain? Yes, Skempton's pore pressure theory. Sure, sure. I'll be explaining you, everyone. Which part in Skempton pore pressure theory for gate examination? Is it how to calculate A and B values? I'll be telling you. Yes. Okay. Listen. Listen, my dear students. Thank you for asking. See what happens for gate civil engineering, especially in geotechnical engineering. This triaxial stress questions or effective stress questions are very, very common. So, Skempton's pore pressure theory plays an important pivotal role in gate examination. So, in order to understand this, why pore pressure develops? Pore pressure develops in undrained loading. In undrained loading, soil cannot change volume. No change in volume of soil. So, any tendency to compress or elongate or dilate any tendency to change in volume, any change tendency, that is tendency to compress, tendency to dilate, leads to pore water pressure. Understood? Why pore water pressure is developed? In undrained loading, when no drainage is allowed, this is soil consolidated in both sides, no drainage is allowed, then what happens? Water is, pressure is applied on water, pressure is applied on water, but water is unable to move out. So what happens? Pore water pressure develops. Clear or not? So generally in Skempton equation, very important for gate exam, that is delta U is equal to B into delta sigma 3 plus A into delta sigma 1 minus delta sigma 3. I'm repeating again. Delta U, change in pore water pressure, equal to B, Skempton pore water pressure parameter. A is also Skempton's pressure parameter. A and B are two Skempton pressure parameters. B into delta sigma 3, that is change in cell pressure. Delta sigma 1 along major principal plane, delta sigma 3 along minor principal plane. Okay. AB are Skempton's pore pressure parameters, and during isotropic loading, delta sigma 1 is equal to delta sigma 3. That means during isotropic loading, when both the values are not given, they assume no shear, drainage is closed, no drainage. That is during isotropic loading. Delta sigma 1 is equal to delta sigma 3. That is, this value will become 0. This value will become 0 means into A also becomes 0. A becomes 0. That is, delta U is equal to B into delta sigma 3. B is equal to delta U by delta sigma 3. This is how we calculate B. And how to calculate A? A equal to delta U by B into delta sigma 1 minus delta sigma 3. This is the value. A is negative for over consolidated clay. And we calculate A by using this formula, delta U by B into delta sigma 1 minus delta sigma 3. So this is the important concept about Skempton's pore pressure theory related to gate exam. These are the equations as well. No need to do much research on this. Just remember these formulas, go for gate exam. That's it. So for tonight, I am winding up the session, my dear students. Thank you, Ashika. I am winding up the session, students, for tonight. We'll be having two sessions back to back, 9 to 11 a.m. tomorrow in the morning, 11:30 to 1:30 a.m., 1:30 p.m. tomorrow in the afternoon. Okay. Thank you. Have a good night.